In this video, I'm going to show you how to use your ESP8266 Wi-Fi module. This is a microcontroller independent tutorial, meaning that the stuff you learn in this video will apply to any microcontroller that you use. So let's go ahead and get started. First thing I want to show you is the command syntax for your module. So every command is preceded by AT+. Then you type the name of the command, so you will replace the brackets and the X's with the command name in this case. So I have an example here that the command is called CW mode. And if you put an equal sign and then a question mark after the command name, then you get a list of the valid parameters. So let me go ahead and show you the output of that command, and I will show you how I'm interfacing with the module in a moment. So if I send AT+CW mode equals question mark, also at the end of every command you have to type /r/n, which stands for carriage returned, and then new line feed. So I'm gonna go ahead and click send. So the equal sign and the question mark after the command tells you the possible values for that option. In this case, the possible values for CW mode are 1 to 3. I will explain the commands in a moment. Right now I'm just showing you the syntax. So like I said, this tells me that I can give the values 1 to 3 to the command. If I want to display the current value of a particular command, I just have to type the question mark after it. So for the same command, I'm gonna type AT+CW mode question mark. So that tells me that the current value that CW mode has is 1. If I want to give a value or assign a value to a command, I have to simply put equals and the value that I want to assign. So in this case, I'm setting CW mode to 2. Remember that the possible values are 1 to 3. So now that I set it to 2, let me use the display value command to show you that it worked. So now notice that previously the CW mode value was 1. Now the value is 2. Let me go ahead and change it back to 1. So that is the syntax for looking at the possible values, the current value, and setting a value. Now what if there are actually some commands that have multiple parameters, so you have to assign multiple values? One of the commands is the join access point command, which is AT+CWJAP. So JAP stands for join access point, and that command is used to join a Wi-Fi network, or in other words, how to connect to your internet router. So if a command has multiple values, then you have to separate each of the values with a comma. And if the value can be either a number or a letter, or if it can include letters and numbers, then you have to put it in quotes. If it can only be a number, then you don't have to use quotes. So in the case of a username or a access point name, which is SSID, and the password for the SSID, both of those can either have numbers and or letters, so they have to be put in quotes. So let me go ahead and show you how you connect to a router. So I'm going to connect to this router. I actually have two routers. So this is the router that I'm going to connect to. So my SSID is AT+409. So I'm going to type CWJAP AT+409, comma, and now I'm going to type my password. So the password for this network, so this is a password. Actually, that number is something that I put at the end so I don't connect to this router, since this is my low speed router. So the password for this router is actually this one. So I'm going to go ahead and type it and then send the command. And it's gonna take just a couple of seconds to join the network. So as you can see here, it has joined the network. I have received the value of OK. Let's see what happens if I type an incorrect password. So this will probably take a while to verify it. So notice that it says fail. Let me go ahead and connect to it again. So the OK and the fail are responses that I'm getting from the module. I'll show you the circuit that I'm using in a moment. So that is how you can use a command that has multiple values. There are some commands that they just display information or do something in particular. For example, there's the reset command that resets the module. This one, I believe, gives you the firmware version of the module. So let's go ahead and use that one. AT+GMR. So that is my firmware version. CIFSR gives you the IP address of the module. So that is the syntax for the commands. You can find the commands online in many websites. I'm going to be posting the links to the websites where I found the commands that I'm using. So this is one of the websites. This is the Chinese datasheet for the module. So this one has all the commands in case some of the websites are missing them. You will be able to find them in this datasheet, and I will post the links to everything that I'm showing you here in the description of this video. So now that you know the command syntax, let me go ahead and show you the connection, the circuit that I'm using, and all the equipment. So this program that I'm using is called RealTerm. It's a program that can read serial ports. So my settings for this program are my baud rate is set at 9600 and my port is 22. So this is a port where my module is connected to. So if I go to computer management, you're gonna see that I have one USB serial port, and that is COM22. So that is the port number that I have here. You can find the baud rate and the if you bought your module from eBay, you can scroll down, and in the case of the seller that I got it from, it tells me the speed that I need to use. So this is the speed that I need to use. And this is the data bits, the parity, and the stop bits. So that is my configuration here. The parity is none. That's what the N stands for. Data bits 8, baud 9600, stop bits 1. So you can download this program from this website. I'm also using a 5 and 3.3 volts power supply that I got from SparkFun. So this is what I'm using for powering up my circuit. The adapter that I'm using for this power supply is this one. So the way I'm connecting this module directly to my computer is through an Ftdi to USB cable. So this is a pretty neat cable. It lets me connect any device that has an RX and TX pin directly to my computer. So this is a cable that was meant to be used for the Raspberry Pi, but I'm using it for this since it has the same interface. So the cable has three connections: a black cable that's for ground, the orange cable is the TX pin, and the yellow cable is the RX pin. And then of course the Wi-Fi module. So this is my circuit schematic. This is my Ftdi cable, Ftdi to USB cable. So the RX pin from the module goes to the TX pin of the Ftdi cable. The TX pin from the module goes to the RX pin of the Ftdi cable, and then the grounds are tied together. So you can replace this Ftdi cable with a microcontroller. The microcontroller should also have a TX, RX, and ground pin. And I'm powering up the circuit from 3.3 volts. So the power supply that I bought gives me the option of using 3.3 volts, which is what the module needs. And then of course there's then from my cable it goes to my computer, and that's how I'm sending and receiving the commands. But you could do that from a microcontroller, but this I'm trying to keep it as microcontroller independent as I can. And then in other videos I'll show you how to use the Arduino and other micros that I use. So let's go ahead and do a real application. Let's go ahead and get the weather from the internet. So the first step, of course, is to power up your circuit. Let's go ahead and reset the module. So let me go ahead and open the terminal. So I'm going to type AT+RST/R/N. And let me go ahead and clear the screen so you can see the output of the module. So let me go ahead and send that command again. So I receive an OK, and then I receive some other information after the reset. Now let's go ahead and join the access point. So once again, I'm using the CW join access point command and my router's name and password. So I've joined the access point. So now we are connected to the router. Now before I show you how to get the information from the internet, I need to show you the website where I'm getting it from. So there's a website called OpenWeatherMap.org. So if you go to this link, and they have several information they can provide you with. We're going to get the current weather data. So that is what is happening right now in a particular city. They give you the formats that you can use. So the one that we're using is we are searching by city name, and they give you an example. So if you wanted to look at the weather in London, which is in the UK, you would put this in your browser. So I click on it, it takes me to this website, and then it gives me a bunch of information, not just the weather, but my weather information is actually located here. This is the temperature, that's in Kelvin degrees, pressure, humidity, which I assume it's percent RH or relative humidity. If I wanted to get, for example, San Francisco, and that's in the US, press enter. So that gives me the information for San Francisco. So what we need to do from the module is we need to go to this website, and the way we do that is we start first, we connect to the website. So this is how we connect to the website. So notice that I got this website name from here. So that's what I put there. So you always put TCP, name of the website. The port that you're using is normally it's 80, so just go with 80. So I'm using the command CIPSTART, and I have to do, now the problem with this is that if I have to do the following 3 commands fast, otherwise I'm gonna lose connection to my network. So this connects to the website. If I don't send the other ones fast enough, then I will lose connection to it. So let me go ahead and explain to you the other 2 commands that we need to send after this one, and then I'll just send them fast when I'm using RealTerm. So now that you know the syntax for this command that connects you to the API, after you're connected, you have to send the data bytes, the number of data bytes that you're sending. So you need to tell the module how many data bytes you're sending. So how do you know how many data bytes you're sending? Well, you have to know a little bit about HTTP requests. In the case of this API, this uses an HTTP GET request. The reason I know it's a GET request is because at the end of the URL, in a GET request, you always see the question mark. Then you see a parameter name, the equal sign, and then the value of that parameter. So that's how I know that this is a GET request. So then I type GET. This is the path for the API. So that would be whatever is after the URL, or after the main website name or the main API name. So you send the type of request, the path. There's actually a space between US and HTTP, so in case you can barely see that, but there's actually a space there. After that, you send the HTTP version. Then you want to send the /r/n, which signals the module that you're about to send another command. Then you give it the name of the host API. So once again, that's the name of the website. So in this case, this will be the IP address, but we can also use the website name. But in here, you have to actually use the website name, or you might be able to actually also use the IP address in this example. So that would be your host, and then we have to send this number of characters. So /r/n 3 times. So let's go ahead and get the data. So I'm gonna copy this line, paste it, send it. Notice that my module says that it's linked. Now I'm gonna tell it the number of data bytes that I'm sending. So I'm sending 85. And then the module replies with this greater than character. And then I send my HTTP GET request. And I get the response that I was expecting. So for San Francisco, it tells me, like I said, more information, longitude, latitude. Let me go ahead and find the temperature. So that is the humidity, 93%. That's the temperature, 284.42 degrees Kelvin. Now, one thing I forgot to show you is how do you know how many data bytes you're sending. So the number of data bytes is the number of characters in this string. So if you count the number of characters that you're sending from when you start right before get, so that's 1, 2, 3, 4, all the way to here. So the last 2 characters don't count, since they are the ones that the module uses to know when you have terminated a command. So only count these characters, and of course /r is 1 character, so those are not 2 characters, that's just 1. /n is another character, that's the new line character. And also make sure that you count this one as only 1, and this one is just 1 also. So if you count the number of characters from here all the way to here, you will see that there are 85. And so that's how I get my data length that I use in the CIPSEND command. Now, of course, this isn't a very good API response that we can work with, but your microcontroller probably has a library that can parse this type of response. This type of response is known as a Json response. So we go back to the API's website. You will see that it says that it can provide you with a JSON, XML, or HTML format. These are the ones that are most commonly used for communicating or sending data through the web. So look for a library for your microcontroller that can parse JSON and or XML data. And that is how you use the ESP8266 Wi-Fi module. Thank you for watching.